Okay, so with an isosceles triangle, it has two congruent sides. And the thing that's true about triangles is if two of the sides are congruent, then the angles are congruent across from them. Alright? Now, I know this is silly, but some people get confused by this. Okay? Sides are where the lines are. Okay? If you put a little line on the sides, those two sides right there, that means those two sides are congruent. Okay? If they had two lines on that one but one on the other, that does not mean congruent. They have to have the same number of lines on the sides to be congruent. Okay? So, those two sides are congruent. Well, when you're talking about isosceles, if the two sides are congruent, the angles opposite them are congruent. Okay? So when I think about what angle's opposite up there, if that's the side, the angle opposite's there. And if that's the side, that angle is the opposite one. Okay? So when I talk about the two angles that are congruent, I'm talking about this angle and this angle. And again, if they have markings on the angle, they have to have the same symbol. If they got one little arc on the angle, then the other one has to have one little arc on the angle. If it has two little marks, that's not the same. It has to have only one. Okay? But that would be the markings for that triangle. Two sides and the two angles opposite are congruent. That's isosceles. Okay, so look at some examples here. So on that first example, I want to find x. What do these two sides right here mean when they have those two little lines? The sides are congruent. If the sides are congruent, the angles opposite are congruent, so what's x? 55. Okay, look up here. These two sides are congruent. So what do I know about the angles? They're also congruent. Well, that's x. What's that? That's also x. Okay. This is 90. If the other two angles are congruent, how could I figure out what they were? Okay, so if I know that one angle is 90, the other two angles together have to be 90. Do you agree? If the other two angles together have to be 90, and I know that they're the same, then I'm going to divide them by 2, and I would get 45 for both of these angles. And if you just wanted to check, you could take 90 plus 45 plus 45 to get 180. Questions about that one? Okay, the last one. Okay, these two angles are the same. Two sides, I'm sorry. These two sides are the same, because that's where the marks are. So what two angles are the same? The top two, because it's the angles opposite them. Okay? So 3x is on the top left. Well, what's this one that's not marked? 3x. Okay? I don't have any numbers here, but I need to figure out what x is. What do I know about all those three angles? They're all add up to 180. So I have to use the fact that, okay, it's isosceles because I see the two sides. But then I have to use sometimes the fact that all three of those angles add up to 180 to solve for it. So I'm going to have 3x plus 3x plus 4x equals 180. So 3 plus 3 plus 4 is 10. Divide by 10. And we get 18. Any questions? Got it? Okay, let's talk about equilateral. So we've already said equilateral triangles have 3 congruent sides. Well, if the sides are congruent, what else is also true? 3 congruent angles. Okay, so if I go over here to this little triangle and I mark it all, well, all the sides would have to have a little line, meaning all the sides are congruent. And then all the angles could have their little thing. Let's talk about these angles, though. They all add up to 180, right? All three of the green add up to 180. If they're all the same, how could I figure out what each one is? 180 divided by 3. Well, what are they? 60. In an equilateral triangle, the angles are always 60. Okay? Either know it or just find it every time, but the angles in an equilateral triangle are always 60. Now, when I look at my examples down below, that does not mean that these sides equal 60. Okay? Be really, really careful. What I have seen in the past, students get confused between the angle and the side, and they start setting sides equal to angles. Okay? You can't do that. Sides equal sides, angles equals angles. Or you can do things like the angles add up to 180. Okay? Just be really, really careful about that. None of these sides here equal 60. Only the angles do. Alright? Okay? Let's look at the first example. Those are sides. Those are not angles. Okay? What do I know about all the sides here? They're all the same. So 2y equals 10, y plus 5 equals 10. They all equal 10. Okay? So pick a side. It doesn't matter because they both have a y on it. You can either set these two equal to each other, or you can set these two equal to each other, or these two. You can pick any two sides, and it will work. If it were me, I'd probably do the 2y one. But you can do the y plus 5 one if you want. Alright? Divide by 2, so what do you get for y? 5. Any questions? Okay, look at the next one. What do I know about all the sides? They're all the same. Well, it doesn't matter that I don't have a number here. It doesn't matter. Because I'm just trying to find y. And if I know that all of them are the same, then I know the two that have something on them are the same. So I just set those equal to each other and then solve as well. If it were me, I'd probably subtract 2y on both sides first. And then add 3. And then divide by 2. Alright, last question on this page. Alright, these things that I see right here, are they sides or are they angles? The 8y minus 10, that's a side. What about 4y plus 2? That's a side. Okay, well, I don't have any markings on the sides, so I'm not sure about that. But what do I know about the angles?
They're all 60.
They're all 60. They're all congruent. If the angles are all the same and they're all congruent, what does that mean about the sides? They're all the same as well. Okay? I don't have to use the fact that they're 60 to solve this because these are sides. Okay? But the fact that all the angles are the same, meaning the sides they're the same, and so I just set the sides equal to each other to solve. So it's the same as the previous example, they just have different things marked. Okay? And that's what gets a little bit tricky because you got to figure out, okay, what are they trying to tell me and how does that help me solve the problem? Okay? So subtract 4y on both sides and add 10 and then divide by 4. On Monday we talked about proofs a little bit and I told you I'm going to give you proofs and we're going to continue to work on them, but most of the time I'm just going to ask you for the reasons. I'm not necessarily going to ask you for the statement. So this is a good example because you can see all the statements are already there. And what we have to come up with are what the reasons are. Okay? Now, the first statement isn't there, but what is the first statement? Always, always, always. It's always given. And if I look at what's given, then I know that that's DE is parallel to BC. Okay? They also, in number 2, told me that angle 1 was congruent to angle 2. What's the reason for that? It's still given to us. They still told me that angle 1 was congruent to angle 2. So let's look at the picture just a second. What they've told me so far is that angle 1 is congruent to angle 2. Okay? Alright, next, they tell me that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Look at those angles. Look at the red and look at the blue. Most of the times when they talk about angles, then what you write down is the kind of angles that they are, because that tell you why they're congruent. So what kind of angles are the red, and what kind of angles are the blue? They are acute. What else? Because just because they're acute don't mean they're equal. Are they vertical? No, they're not vertical. Are they same side interior? No. Okay, keep thinking. What other kind of angles are there? There is one that starts with a C.
Compression.
Corresponding. So this one, the reason is corresponding because those angles are corresponding.
What? Isn't there compression angles too, though?
Compression is where you have a graph and it squeezes it together.
Sorry.
Okay, next. So there's angle 1 and angle 4 and angle 2 and angle 3. And also we know that angle 1 is congruent to angle 2 because we've already figured that out. It told me that. Okay? Next it says angle 2 is congruent to angle 4. Angle 1 is congruent to angle 2. Angle 1 is also congruent to angle 4. So why is angle 2 congruent to angle 4? Substitution. Yes, we can use substitution there. Because it's like you're plugging the angle, I don't know, angle 1 is congruent to angle 2. It's kind of like you're plugging angle 2 right there, if you want to think of it that way. Okay, look at the next one. Angle 3 is congruent to angle 4. So if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, why is angle 3 congruent to angle 4? Same method. Okay. Last step is usually what it says on prove. So let's write that down and let's figure out why. AB is congruent to AC. The last thing that we did before that is we said that angle 3 was congruent to angle 4. So these bottom two angles are congruent. So why are these sides congruent? So bottom two angles are congruent. The bottom two angles are congruent. What kind of triangle is that? Isosceles. Isosceles says if the bottom two angles are congruent, the sides are congruent. And so the reason is isosceles triangles. Questions? If you look at number one says AC is congruent to AD. Okay, I'm going to highlight it. AC is congruent to AD. Those two sides are congruent. So if those two sides are congruent, what two angles are congruent? This one and this one. Does that make sense? And D, it'd be okay to say angle D, but it's not okay to say angle C because there's lots of angles at C. C needs to be in the middle when you say that angle. I would probably say ACD. Okay? You can't say C because there's so many angles at C. Alright, let's look at the next one. The next one says BE and BC. So BE and BC. So those two sides are congruent. So what two angles are congruent? This one here at E and this one here at C. Okay. But we can't say E and we can't say C because there's too many angles there. So let's think about how we're going to say that. Because we really need this angle right here. And we need that angle. I heard BEC. And then I heard, wait a minute, BEC, yes. And then I heard BCE. Whatever the angles are that are congruent, that little thing there at the angle, that has to be in the middle. So we have to have an E in the middle, and we have to have a C in the middle.
Yeah.
And then whatever two things are around it. Alright, let's look at the next one. Okay, EBA. So just follow E to B to A. E to B to A. That is congruent to EAB. EAB. So basically the two angles that's talking about, and it's hard to see, is this angle and that angle. Okay, they're telling you those two angles up there are congruent. If those two angles are congruent, what two sides are congruent?
BE and AE.
BE and AE. They're not all three congruent unless that angle down there at E is congruent to those. Okay, let's look at the last one. CED. So follow C to E and then to D, so that means this angle. Okay, and then follow C to D to E. That's the angle there that's marked. So there's the two angles. Now what two sides? The two sides across from it. So this side and that side. So CE and CD.
Yeah. We're done.
Alright, yes. So if these two sides are congruent, the two angles are congruent, so that's 60 and that's the angle it's looking for. Oh, number 6, these two sides are congruent, that means these two angles are congruent. Okay? Now up there in the corner it has a 40. So how can I find the blue angles together? So subtract 40 from 180. I get 140. So 180 minus 40 is 140. And that tells me the two blue angles at the bottom, they both together equal 140. But they're the same. So divide 140 by 2 and we get 70 for both. Alright, number 7. The two bottom angles are equal, so what does that mean about the sides? They're equal. So subtract 2x on both sides. Add 10. And you get 14. Last one. These two sides are congruent. So what does that mean about this angle right here and that angle right there? They're congruent. Well, that doesn't really help me a lot. But I see that there's a 90 up here. And I know these are congruent. So if I take 180 and subtract 90, I get 90. That means these two angles at the bottom are equal to 90 together. But they're the same. So divide them by 2, like I did up on number 6, and you get that each one's 45. So these are both 45. Now, we know that that 45 one's 2x plus 5 equals 45, so now we just solve, subtract 5 on both sides, and divide by 2.